This episode of Hansel Minutes is brought to you by Partner Hero. Partner Hero provides customer service outsourcing that's built for the needs of scaling and high-growth startups. They offer flexible terms, fast onboarding, and the ability to scale teams quickly, which is great for fast-growing businesses. Now, in the past, outsourcing has had a bad reputation for being exploitative or somewhat, low quality. Partner Hero's values-based approach really raises the bar. They pay above-market salaries. They have a focus on quality and performance. And unlike most business process outsourcing companies, their management team includes individuals from the startup world. So they're more than just a service provider. They're a thought partner for startups that they serve. They've got flexible terms, they've got offices around the world, so they have truly global coverage, including onshore, nearshore, and offshore options. Now, outsourcing has long been available to many big enterprises, but Partner Hero is challenging businesses as usual with short, flexible contracts and fast ramp-up times. If you're ready to bring in outside customer support help for your startup that feels like it's a part of your existing team, check out Partner Hero. Head on over to partnerhero.com/HanselMinutes to book a free consultation with their solutions team. Mention that you heard about Partner Hero from Hansel Minutes and they'll waive the setup fee. That's partnerhero.com/HanselMinutes. Hi, I'm Scott Hanselman. This is another episode of Hansel Minutes. Today I'm chatting with Aaron Giles. We're going to be talking about emulation. But first, sir, you've been around a while. You've been coding for 30 plus years. Is that right? Did you teach yourself or do you have a PhD in something?
No, I've been programming since I was a kid. When I was growing up in the late 70s and early 80s, I really wanted to write my own video games. And that was the driving factor to make me want to learn to program. And at the time, I knew that programming video games involved writing assembly language. And so even though I didn't have the greatest computer for that kind of thing, I started writing on assembly language in BASIC and have been programming ever since.
So you found your thing. My kids are 15 and 17, and I want them to find their thing. I don't know if it's what it is. They haven't found it yet. But when you find it, you just know. Did you know right away?
Oh, yeah. I absolutely knew that was my thing. And I agree with you about wanting that for your kids and, kind of hoping that they'll find that thing that they lock into. But I just think it's a matter of luck. And if you luck into the thing that you love and just want to be doing, then you go for it.
Mm-hmm. So I want to kind of discuss a little bit of your resume so that we can kind of establish your bona fides, as the kids say. So you worked at LucasArts. You worked on SCUMM. What does SCUMM stand for?
So SCUMM is an acronym for Script Creation Utility for Maniac Mansion. And it was an adventure game engine that was developed for the Maniac Mansion game, which came out in around 1987, if I'm not wrong.
Right. And we have other classic games like Day of the Tentacle and Indiana Jones. Are these point and click kind of like games that really defined that era. And then you later worked on Connectix, which turned into Virtual PC, and Virtual PC turned into Hyper-V, and you spent almost 20 years at Microsoft as a principal engineer working on everything from Hyper-V to ARM. And all the while, though, you were doing open source. So you were working full-time and coding at night because apparently you just don't know how to stop.
It's kind of true. At least in my case, I found my passion, and my passion turned out to be emulation. And discovered it in around 1997 with the Stella emulator, which was an Atari 2600 emulator. And it was wanting somebody to do their Mac port, and I was a Mac guy at the time, so I was like, sure, I'll do that. And shortly after that, discovered MAME, which was originally the multi-arcade machine emulator, and that was emulating arcade games, which is what I grew up on. And to me, that was the thing. I mean, to me, that was the holy grail. The whole reason I had consoles or computers was to be able to play the arcade games that I saw in the arcades, because to me that was the pinnacle of technology. And so here we were being able to actually emulate them on the computer with seemingly perfect accuracy. And I said, that's what I want to do.
Yeah. And actually, I don't know if you can see, but behind me is a MAME. I have a multi-arcade machine emulator. It actually says MAME across the top, and inside it is a PC. I went and I built that arcade cabinet from scratch. And for me, having an arcade cabinet in your house is the pinnacle and the glory. That's just if I could just do that. I wish that young people could experience what we experienced, like lining up quarters on an arcade and what that felt like. And now in my hand, I'm holding another MAME machine, which is a tiny arcade that has a Raspberry Pi inside. And I actually have about 10 different arcade emulators around the house in various forms because I can't stop. And MAME really kind of started it all. Why do you think emulation is so important? Like it captured your attention, but is it just about preserving history or is it something else?
The nostalgia is a big factor. I mean, nostalgia is a powerful force. I think we can all agree. But I mean, preserving history from a practical point of view is huge. I mean, there are folks out there who want to play on the original hardware. They keep their original Atari 2600, or they might have their own original arcade cabinets out there, and keeping those things running is a dedicated job. I mean, they spend half or more of their time not actually playing the games, but working on them to try and keep them going. These things are going to fail eventually. And it's even worse for computers because the media, those floppy disks, those definitely aren't lasting forever. And even the ROM chips that the video games were programmed onto for the arcades, those things are deteriorating. You have bit errors if you try to read them now. And so that stuff is at risk of being lost. And so to my mind, at the very least, preserving the media to go forward, so that you have the possibility in the future of having the original code to work with. That's a big deal. But then just also to expose next generations to what it was like without having to trot out the giant arcade cabinets. The fact that, if you want to play the original Pac-Man, if your only experience of it was to play it in the arcades, yes, that's the best experience because that's what you actually were physically there in front of a machine, a giant cabinet with a particular joystick and the sound that were kind of surrounding you as you leaned into the cabinet. That was a very visceral effect, but you can recreate that. But the recreations, you run the risk of, if you're not attempting to recreate the actual behavior of the software at the lowest level, it's going to be hard to really have the same effect. And so I think emulation goes a long way toward kind of bridging that gap, to kind of bringing things forward into the modern era without having to bring the hardware, which is actually the hardest thing to keep going.
Do you remember how did someone emulate things before MAME from a game perspective? What existed before MAME?
I mean, prior to MAME, there were several emulators. I mean, MAME certainly wasn't the first. It just kind of became one of the biggest. My earliest memory of that kind of stuff is Digital Eclipse released for the Mac a set of the original Williams games, Joust and Defender and Robotron, and they had written an emulator for those games specifically, and you could buy them. It was like $30. You'd buy it and you'd get like Robotron, and that's all you got. But you got Robotron, and you could play it on your Mac at full speed, and they were emulating the original system games as closely as possible. So it was my first experience with arcade emulation. But I mean, even then, there were open source or at least free emulation systems out there. Everybody focused on their favorite game, and I think that's kind of how it grew out. And it certainly is what got me into it, is sort of like I saw MAME and I said, well, it's cool that it emulates Pac-Man and a few other games, but I really wanted to emulate Mappy, which people weren't really into. And I thought, well, is there some way that I could, because the source was available, I thought, well, can I learn enough to be able to be the guy who gets Mappy up and running for the first time on MAME, and because nobody else was emulating it. And so that's what was sort of my entry into things. And so at the time, I think everybody was sort of picking their favorites, and that created sort of this collection of emulators. There were several sites out there you could go to that would, retrogames.com and stuff like that had all these. You could keep your tabs on all the different emulators, and that still happens today. I mean, you have all these emulators for all the different consoles and various other systems now. And so that aspect hasn't changed too much, but a lot of it did consolidate into MAME because of its design and flexibility. And I think that's sort of to its benefit, and how it kind of became the granddaddy of the big arcade emulators.
And you led the MAME project from 2005 to 2011, and you actually created the first official native port of MAME to Windows, so that our audience really understands where you sit in this piece of history. There's a lot of folks that are wanting to get involved in open source and get involved. I assume that you start by watching this project and going, I want to be a part of that. Like, is MAME is it an organization? Is it a bunch of loosely federated people? How do you become the project lead of something like so significant like that?
It's really just a bunch of guys, honestly. It's when I signed up, it was led by Nicola Salmoria. Pardon me if I butchered his name, but he's the original creator of the multi-pack emulator, which is what became MAME. And when I joined, he was still in charge of the project. But already there were several dozen people contributing. They were finding new games to emulate. They were working on emulating new microprocessors. At the time, it started as a Z80 only emulator and eventually added more, the 6502 and the 6809, and expanded into 16-bit chips like the 68000. And so there was just a lot of people working on it. But I mean, Nicola was still coordinating it, and he would put out the official releases. And at the time, there was no source control or anything like that. It was really just you sent your files to him, and he would incorporate them into his build, and his build was the official one. He'd put it out. And then after a while, I think he had to go for military service, if I'm remembering correctly, in Italy. And he disappeared, and he handed the reins over to another developer. And he ran this thing for a while, and then another developer took over. And so it kind of was passed off from person to person as the team was growing and getting bigger. And eventually, it just got to a point where the guy who was currently in charge was being very frustrated with, all the work he had to put in to make a release, because the project was getting bigger and bigger. Coordination was becoming more and more of a chore. It distracts you from being able to actually work on emulating games because you're too busy being a manager of a project, basically. And so, and I'd been doing a lot of architectural groundwork in the system to try and modernize it, because it was really in kind of a, when you start with something small and you keep adding to it, it requires a lot of technical debt. I almost hate to use that word because it's a little keywordy to me, but it took a long time to kind of build up the infrastructure where, MAME got to be a little more of a bunch of components that are combinable into a system, rather than it used to be that you wanted to emulate a new game, you would pretty much start from scratch, or copy and paste from another driver that already existed and kind of assemble the pieces, maybe write some new emulation bits that you needed to do. But it kind of existed in a silo, apart from the CPUs and maybe the sound chips. Those were the two things that we knew could be shared across multiple systems. So, everybody who used Z80 used the same Z80 emulator. Everybody who used a certain sound chip used the same sound chip emulator. But if you needed like a timer, 6840 timer or something like that, even though that was a common chip, most people just kind of hard hacked that into their driver and said, I'll write just enough of the emulation of this to make it work in the way the game uses it, but I'm not going to write like a generic 6840 timer because that's too much work. And so people were moving fast. They wanted to emulate as much as possible, as fast as possible. That kind of built up a lot of debt. And so we started to consolidate the project and the code a lot when I was kind of stepping up to be coordinator, so that we did find these common pieces and bring them together into their own modules, start to flesh them out so that, maybe you have a 6840 timer that implements all the modes of the timer, which was probably quite a lot, so that every driver that had a 6840 in it could use that timer and share an infrastructure. And so that was sort of the beginnings of, where we ended up going with the overall architecture. And I'm not saying I did all that work, but I worked a lot on providing the structure upon which all this was built, kind of defining the structure, it was kind of funny because the MAME was written in C, but it was written in a very object-oriented design. And so eventually we moved to C++, but that was actually quite a bit farther down the line. And so it seemed a totally natural fit to me. I was looking at it for years thinking, boy, it'd be really nice to move to C++ because pretty much we're writing, vtables and all this other stuff in C, and it was getting quite unwieldy. So kind of evolved that way.
You use this word driver, and when I think of drivers as a technical person, but not at the level that you're talking, I think about, I plug in a physical piece of hardware. It's a Sound Blaster card or a USB keyboard, and that's the driver. But in the context of MAME, a driver can be a CPU, or it could be a sound card, or it could be the entire cabinet, right? Like it's a driver, it's a game driver. So it's a kind of an overloaded term?
It can be. Usually when in the context of MAME, when we speak of a driver, we're referring specifically to the description of a system, of an entire system, like of an entire arcade cabinet or an entire computer. We usually refer to what you're talking about, like a sound chip or a CPU. Those are devices. And so we kind of just call those devices. At least that's the nomenclature that we kind of ended up with in MAME. We have many, many devices in MAME and many, many drivers. And the drivers usually assemble the devices into some kind of, interconnected web of signaling and memory maps and stuff like that in order to create a working driver. And so you'll hear driver, the term used driver, mostly used to refer to entire systems. A driver can actually be a device, and that's sort of an interesting thing because, for example, when we were supporting Laserdisc video games, was one of the things I worked on early on. Laserdiscs themselves are an entire machine, and so you can emulate a Laserdisc machine by itself, a standalone player. But when you're in the context of an arcade game, that's just another device that's plugged into the main cabinet, which is there. And so we actually kind of did leverage that whole drivers can be devices thing in that way, so that you can kind of create a standalone Laserdisc player, or you can use it as a device in another system.
So I'm imagining a theoretical arcade game. Someone discovers an arcade game. Maybe they find, like copies of E.T. in a trash can somewhere, and they say, "Look at this board." And they open the cabinet and they have a board in front of them, and they say, "Here's the ROMs. That's what the game is." Do they then look at the chips on the board that was invented by Midway or Williams or whatever, and they say, "All right, we got a couple of 6502s. We got a this. We got a that." Are they sitting there with a magnifying glass and then trying to map physical reality to software reality?
I'd say the way we approach it has evolved quite a bit. So I would say in the early days, a lot of times all we had were the ROMs. We had to figure out, and we had to guess what was behind them.
Goodness.
So you didn't even know what CPUs they were in a lot of times, because what happens is a lot of the ROMs came from arcade operators, and the arcade operators would back up the ROMs just in case, they needed to reprogram them, or there was a new version that came out or whatever.
And that's a legitimate thing, just to be clear. Backing up ROMs, like you own an arcade, you own 200 arcade devices. That's your money. You back those ROMs up in case something bad happens.
Yeah, certainly that was the idea. And then if your machine fails, one of the first things you would do is reprogram the ROMs to make sure that there wasn't some failure in the device or something like that, because that's an easy thing to check. Or you'd read the ROMs that you were in your machine and compare them against the ones that you knew were good, and see if you had any bits that were different or something like that.
Okay.
And actually, that's one of the things that MAME can do quite well, is it's got a giant database inside of it of all the ROM chips of all the arcade games that it's emulated. And you can actually cross-reference. You can give it a file and say, "Hey, is this in your database?" And it'll do a CRC check to see if that chip is known and what game it belongs to. So sometimes you'll end up, as an arcade operator, you'll find a box somewhere that has a bunch of loose ROM chips. You don't even know where those came from, and you can read one of those and look it up in MAME and say, "Oh, that's from Ladybug or some other game that you weren't sure of."
Oh wow! Okay, so then you may not have the board. You're trying to figure out what game this is and what to even emulate. How would you even build a driver from looking at a ROM?
So if all you had were the ROMs, which a lot of us did in the early days, you'd take a disassembler and run it against the ROMs for all the various architectures that you knew about. So you might have a Z80 disassembler, and you'd say, "Well, if I disassemble this as Z80 code, does that look like real code, or does it look like gibberish?" "Oh, it looks like gibberish. Okay, well, I'll run it through a 6502 disassembler. Does it look like code or not?" And so a lot of the times we did spend actually trying to identify that. And then once you had it there, once you figured out what CPU it was designed to run on, you had to figure out the memory map, basically how the memory is laid out within the system. And so you knew that there were certain locations in the memory map where it would find the starting code. And so you'd find code that looks like the starting code, or in the case of things like the 6502, you'd find the vectors at the end of the ROM, which say, "Here's where the starting code is." It'd be an address where the starting code is. So if that all looks legit, if you could assemble that and say, "This all looks like legitimate code," then you just start looking and seeing what it does. And what an arcade machine does when it starts up. It tests the hardware, clears the RAM, it initializes the variables, and it starts the attract mode. And so you just kind of see what it was doing, what it was accessing, and you'd guess how much RAM was there. You could say, "Oh, it's putting the stack pointer here, so in the stack pointer's got to point to some RAM, so there's got to be some RAM where that stack pointer is." And, "Oh, it's clearing a bunch of memory here. Maybe that's video memory, or the graphics go. You don't really know. Or it's writing to something here in patterns that look like how you'd write to a sound chip." Those patterns once you know how most sound chips are set up, you'd be like, "Okay, I can recognize the patterns, that there." And there's a lot of times you don't know what that is. You're just like, "Okay, what's writing here?" And it's expecting to read back, this bit changing every once in a while. So, a lot of times people would say, "I'll just randomly return a 1 or a 0 on this bit, and eventually it'll, get out of this loop and keep moving forward."
This episode of Hansel Minutes is brought to you by User Interviews. User Interviews connects researchers with quality participants. Participants earn money for their feedback on real products. There is high demand for software developers and engineers to provide feedback on products being created for developers. It's free to sign up, and most studies are less than an hour and pay over $60. Some studies pay several $100s for a one-on-one interview. You can share your opinions with top brands, Adobe, Intuit, Spotify, Amazon, and many more. Are you ready to earn extra income from sharing your expert opinion? Head over to userinterviews.com/hello to sign up and participate today. That's userinterviews.com/hello. Are there moments like I'm trying to imagine what it must feel like. It's 2 a.m. on a Tuesday night. You have your day job, and then suddenly, you're working on the side on MAME, and you get Mappy or Pac-Man or Joust to boot up. Is it the screen goes black and you see a ROM dump, or like is it a moment, or is it a series of small moments that you've done it?
It's usually a series of small moments. A lot of times in the early games, you didn't quite know how the graphics were set up. Every game had its own custom hardware thing, so it's not like it was a bitmap display like we have in modern systems. So, you had to guess, how that data was laid out. A lot of the time, the data was in ROMs as well. So there were a lot of tools that you could use to say, okay, well, what's the bit pattern in the ROMs to produce things that look like 8x8 characters? Because most of the games had, sprites or tiles that were 8x8 or 16x16. And so if you manipulate the bits in certain ways, patterns would emerge to be like, okay, that looks like a character, or here's the text, here's the font. I can see where the font is in the thing. So a lot of times you could figure that out, and then you'd be like, okay, well, when they write an ASCII A at this, into this memory location, if they're writing something that looks like a string, I can be thinking, maybe that's where video memory is. So then I'll try to display a bunch of that memory on the screen as a bunch of characters. And hopefully as the game's running, you'll start to see something appear or starts to resemble the game. But, emulation, I have to say, is one of the most satisfying programming endeavors, because it's a lot of time spent studying minutia. But when you get it going, the aha moment when things are actually running to the point where you're like, okay, we got it to this point, or it's displaying the title screen or whatever, those are so rewarding. It's like a dopamine hit every time you do that. And so, emulating games is like that. Working on virtualization has been like that. Every time I've worked on anything where you bring up a system, the nice thing about emulating something that works, that exists already, is that somebody's already made something cool. Your goal is just to get that cool thing running. So it works at some level, and you just need to get your system to behave well enough that it works. And so when it works, it tends to work all at once. And so that's kind of exciting. It's not like it's incremental in a way as you're getting bits and pieces, but once you kind of get it going, it tends to be kind of a big aha moment where you're sort of like, wow, that's working.
One of the things that you're working on right now is called DREAMM with 2 M's. Now, we mentioned at the beginning of the conversation SCUMM, Script Creation Utility for Maniac Mansion, the Lucasfilm Arts game. I'm used to playing things like Day of the Tentacle and Maniac Mansion inside of SCUMM, but you're creating this DREAMM, DOS Retro Emulation Arena for Maniac Mansion. What is the difference between DREAMM and SCUMM, and why make it when this other thing exists?
So I think you're referring to SCUMM VM.
SCUMM VM,
which is actually yeah. So SCUMM is the system that LucasArts created, which is basically the adventure game engine.
Right.
And SCUMM VM is a modern interpretation of that engine. So basically, the best way to picture it to me, since we're talking about emulation, is that LucasArts designed an imaginary machine, and this machine can run a language called SCUMM. And this imaginary machine, you can call it a virtual machine if you want, has an emulator that LucasArts wrote for various systems that can run that virtual machine, the emulator. So this, for example, the game Day of the Tentacle is written in SCUMM, and then LucasArts wrote an interpreter, they call it, which is the SCUMM engine, and that runs on like your IBM PC or your Mac or whatever, and that can run SCUMM games because you've sort of designed this kind of fake machine.
So it's a jitter, it's a runtime of some kind, right? It's eating some bytecode. The SCUMM is some code that they wrote, and that's very prescient of them to do that.
It's very similar to how Java works. You figure there's Java bytecode, and then there's a Java virtual machine that actually runs it. Well, SCUMM is compiled into basically bytecode, and there's a virtual machine, which is the Sputum, which is the SCUMM interpreter that runs. And that the nice thing about that is they could design the games once in this virtual environment, and then whatever platform they wanted to port those games to, they just had to make that interpreter run on it, and then the game just kind of worked. And so what SCUMM VM has done is basically they've reverse engineered this SCUMM language and created their own interpreter that can run on various platforms. So they're basically kind of replicating that piece that LucasArts wrote. My approach is I can run all the same games, at least the LucasArts games, but instead what I'm doing is I'm emulating an IBM PC, and therefore I'm running the LucasArts provided interpreter for the games, but then running the one that they wrote for the IBM PC, and then it is in turn running the SCUMM games on top of it. And the advantage of that for me is that SCUMM relies on reverse engineering, which is hard and imperfect because you don't have the original designs. You're not working on that. But they've done an amazingly good job. I don't want to say anything negative about what they've done because it's actually quite an impressive job. Whereas what I'm emulating is a very well documented thing, which is an 8086 processor and a bunch of peripherals that everybody knows how that works. And so in theory, if I do my job correctly, then running the Lucas interpreters on top of my DREAMM emulator should provide the exact same experience as running it on a real IBM system. Now, obviously, there's limitations to that. But sort of my approach was people have been running, and you might look at the other side and say, well, you've written an IBM PC emulator. People have done that a bunch of times too. So what's the interest in that? And to me, there's an ease of use issue. SCUMM is very easy to use because it's designed to run these games specifically. Most IBM PC emulators are not designed to run one particular game. They're designed to emulate an IBM PC. And so therefore you have to know how to set up DOS. You have to find a copy of DOS, install it. You have to install the games. You have to configure your memory, get the right sound card, get the right video card. You have to know the options. So my approach was basically to kind of simplify that and say, hey, can I make an emulator underneath, but put the ease of use on top of it that makes it as easy to use as something like SCUMM. And so that was sort of like kind of creating a hybrid thing.
The thing I find so fascinating about that is how many ways one can solve the problem and get pixels on the screen in quote unquote mostly the same way. So you could use DOSBox, which is a kind of an emulator, but not like a Hyper-V kind of emulator. You could use Hyper-V. You could run Windows. You could even go and take a WebAssembly version of a DOS emulator and then run SCUMM within that. And these are like 15 different layers that you could attack the exact same problem. And is one of them right? It depends.
Yeah, it really depends. Me, I find emulation fun, and I wanted to do this project. I had other motivations to do it because since I actually did a contracting job for LucasArts back in 2003, where I made modern Windows versions of all the SCUMM interpreters so that you could run the modern SCUMM games, and they were kind of only lightly released and not really widely shared. And that disappointed me quite a bit because I thought this was a great way to bring people forward on it. And so I'm like, well, what if I could provide a very similar interface, as you said, getting the same pixels on the screen, but in a different way. And the different way underneath was to emulate everything at that level. And so that was an interesting project. And it tapped into a lot of other things that I've had a hand in doing as well. So it kind of built on exactly my history of emulation.
Right, because in the late 90s, like as you said, you ported the DOS-based adventure games to Windows. Are you like waking up neurons that haven't fired in 20 years and bringing back knowledge and like saying, oh, I remember when I was doing that, and now you know more, though, you'll do it differently?
Yes and no. The funny thing about emulation, and I think a lot of people don't quite realize this, is that you don't really need to know what's happening in the software that you're emulating. You just need to emulate the hardware that it's running on. And so a lot of people ask, oh, I see you emulated this game. Do you know how they did X, Y, and Z in the game? And I'm like, I have no idea. All I know is that there was a bunch of software running on me, and they sent me some video commands, and I interpreted those commands and sent them out to the video screen. But I have no idea what the software was doing because I didn't need to. I just emulated the processor. And a lot of it's, and that gives you a hands-off thing. It's like I didn't have to reverse engineer how SCUMM works. I just knew that I had
you have a complete emulator, like you emulated. At the layer you came in at, I did my job. And that's the whole point, right? Because I've talked about this when I teach software engineering, is that layering is lying. So you lied correctly, and you provide such a complete abstraction, a complete lie, that I don't know how they did parallax in that game. I'm sure they're very clever, but I'm 3 levels downstream of them.
Mm-hmm. Yeah, and it also speaks a lot to just modern software in general. Everything's so layered these days. It's the levels of abstraction are getting kind of insane. And so it's hard to know what's going on at the lowest level, but the lowest level also doesn't really know what's going on at the highest level either. It's like there's a complete impedance mismatch between both sides.
What do you feel about FPGA? There's a lot of excitement around FPGA and hardware or kind of semi-hardware emulation, these field programmable gate arrays that are purporting to be more accurate than software emulation.
Mm-hmm. The FPGA stuff is definitely cool. I think it's a bit overhyped at the moment. Not that I think it's a bad thing that there's excitement about it, but I think some people have held it up to perfection as being, this is the perfect emulation of everything, and it can be just as much as software emulation can be as perfect as you can get it. And there's nothing fundamental about the FPGA that makes it better or necessarily faster than software emulation, but there are some things that the FPGA excels at, which is that you can wire things up to execute in parallel and synchronize much more easily through doing it all in logic versus trying to do it in software. And so that's where the FPGA wins. But really where I think the reason why people have such a high on the FPGA is that the people working on it are real pros. I mean, they are going that extra mile. They're taking a lot of what they're doing is taking what's in MAME already, but they're not just implementing it blindly as in replicating what's in MAME. They're going back to the original hardware. They're doing a lot deeper analysis of signals and timing and stuff like that in order to get that extra level of precision and that's great. But that's not inherent to the FPGA. That really means that the people working on developing these FPGA emulations, and they are emulations, let's be clear about that these FPGA emulations of the original hardware they're just being that much more detail oriented, in part because they can, and it's cheap for them to do it in logic versus the complexities of trying to replicate that in software. And so they're playing to the FPGA's strengths in a lot of ways. But I also think that they're just doing great work, and a lot of that's also feeding back into MAME. And so we're getting corrections from the folks working on a lot of the FPGA emulation stuff, where they're like, yeah, hey, we noticed this isn't quite right here because we figured out exactly how this works since we took the time to go that extra mile and figure that out. And so, they're building on top of us, and ultimately we're building on top of them. And I think it's a good symbiotic relationship, but I'd just be a little careful with the hype train. It sometimes gets a little annoying. I think a lot of the software emulation folks get a little frustrated at the hype train on it because I'd say it has as much to do with the quality and efforts being put in by the FPGA developers, more so than the native fact that FPGA is inherently better than or worse than software emulation.
And philosophically, you again are coming in at a different layer. They're trying to simulate how electrons flow around in this rock and make the timing just so. And if there's a flaw in a 6502, and we know these existing known flaws, we're going to emulate everything down to how that voltage goes up on that pin, which is a very different thing than emulating an operating system or a runtime, or what layer did they decide to come in at?
Mm-hmm. Yeah, and so in that way, a lot of stuff just kind of works if they glue it together in the same way as the physical hardware, and you can cross-reference the physical hardware and say, okay, if I'm connecting things there. But I mean, even so, it's they still have some black boxes. It's like a 6502. I don't believe, now I'm not 100% sure, but I know people have decapped the 6502 and they know at the logic level exactly how the 6502 is implemented, but I don't know if the FPGA implementations are replicated to that level. I suspect that they're more black box implementations. They looked at the manual of a 6502, they understand how it interprets instructions, what the inputs and stuff are supposed to be, and somebody's replicated what that behavior is supposed to be, but not at the transistor level. But maybe they have, because 6502 is simple enough to do that. But things like 68,000, probably not.
Right. But then you bring up a great point. At the transistor level, I don't know. Many years ago, I had Ben Eater on the show, and I personally implemented the 6502 in using Ben Eater's kit, using the 7400 series parts. Is that a true emulation of 6502? He was like, well, the lengths of the wires can affect your behaviors and your timings. And I had some weird timing issues. And he's like, yeah, you might have a little resistance on that wire you didn't count on. When you're dealing with quantum effects and stuff like that, it's like, man, who knows? Like, it's a miracle any of this works and that you and I are talking today.
Yeah, and it's funny. I mean, if you look at like the tolerances on the clock crystals that are provided in the games, depending on how cheap they went with their sourcing of parts, you could have a 1% variance on your clock crystal chip, from game to game. And so you may even run things side by side, and you may be running at exactly the stated crystal speed, but because that particular crystal in the board you're running against, is a slight deviance from that, you're not going to be completely in sync. So things like that can happen, and you never, nothing's ever perfect, because none of these things, down to that level, you're never going to be 100%. It's always an asymptotically approaching perfection.
So in closing, where would you send someone who's interested in this space, other than just go download a thing like MAME or DREAMM and start playing? I had Gustav Petsy on the show and from Pakuma, and I'm taking his 6502 assembly class with Stella. There's places you can go and learn these things, but where's a good place to get your feet wet? Because we just talked about the last 40, 50 years of gaming, and this might be overwhelming to a 25-year-old who might be interested in getting in the space. What do I tell them?
My biggest recommendation would be that you want to start small. It may be tempting to look at something like MAME and say, oh, I want to look at how I can contribute to MAME. And there's a lot of small things that can be done there, but I will admit that a lot of them aren't very exciting. When you're learning, don't worry about reinventing the wheel. It's okay. we're always taught, why would you write something that already exists or whatever? It's like, if that's something that's interesting to you, if your desire is to write yet another NES emulator, because that's what almost everybody starts with, or something like that, a Z80 emulator, like that's the simplest thing. But if that's interesting to you and you want that'd be a great learning experience. I would say be curious, take the time to understand how things work. I mean, even the act of compiling a Hello World program for yourself and then disassembling it and understanding how that Hello World program works on a modern system is an interesting thing, because it's teaching you to think like how a compiler works. And that's important to understand, because then you understand how, when you go to reverse engineer something, you'll think about how something needed to be accomplished and what needed to happen to go into that. And so that's kind of an interesting thing. But I mean, it really just takes, I'd say, curiosity and perseverance is probably the other thing. Is like, you're going to run into brick walls. You're going to need to, if you're reverse engineering something, or you're going to have some really hard to find bugs, and you're just going to have to spend some time really just working at it. But so you got to have something that's going to motivate you through that, I would say. But be bold, just jump and get your hands dirty. I mean, if you can watch podcasts and take classes all you want, but for me, throughout my career, it's always been like, my biggest rewards is when I just said, you know what, I'm overthinking this. I just need to sit down and get the thing done that I want to do it. And don't be afraid to say, yeah, I'm going to do it. And I'm probably going to rewrite it 3 times along the way because I messed it up the first 3 times. But, the last time I'm going to get it right, because I understand it. The process of going in and getting your hands dirty creates understanding probably better than anything in my experience doing emulation. And so anything you can do to just dive in and start playing is going to be a benefit.
I appreciate that. The process of getting your hands dirty is where the learning starts. Thank you so much, Aaron Giles, for hanging out with me today.
Well, thanks for chatting.
This has been another episode of Hansel Minutes, and we'll see you again next week.